If we have a straight line on a position time graph, the slope provides us with some useful information. If the slope is positive, then it indicates that the object is moving in a positive direction. Recall that up, to the right, north, and east are often denoted as a positive direction. If you have forgotten this lesson, go review the vectors video. In the example below, the object starts at a relative point 0 and moves to the right. An animation to illustrate this would be the ball moving to the right. If you have a zero slope, a straight line that is perfectly horizontal, that indicates that there's no change in position with time. The object is simply at rest. In our example, the object stays at 2 meters to the right of a relative point and does not move. An animation for this would be a ball which stays in a fixed position for the 5-second duration. If you have a straight line with negative slope, it indicates an object that is moving uniformly in a negative direction. In the example below, an object starts to the right of a reference point and moves left towards the point and eventually will pass the reference point. An animation for this would be simply a ball moving to the left. What is a real-life example of a position time graph like our last example? An example of this might be a golfer who has a ball at rest 1.5 meters to the right of the hole. He putts it and it approaches the hole and passes the hole and continues to move past it to the left. Take a look at this example. Line 1 represents an object starting at a reference point or the origin and moving north. Recall north is the positive direction. It will travel 3.5 meters in 5 seconds. Line 2 represents an object at position negative 2 meters north. Negative represents the opposite of north, south. So the object will start 2 meters south of the reference point and move to half a meter north of the reference point in 7 seconds. Line 3 represents an object starting at 2 meters north of the reference point and move to 1.5 meters south of the reference point over a 7-second duration of time. Finally, line 4. Line 4 represents an object starting at 0, the origin, and moving in the negative direction, south. It will move 3.5 meters in 4.5 seconds. Take a look at this position time graph. It has a series of straight lines on this position time graph, which indicates that the object travels at uniform motions for components of the graph. For the first 6 seconds, the object will move north 2 meters. From time 6 to 10, 4 seconds, the object remains stationary, or at rest. From time 10 to 12, the object will move from 2 meters to 6 meters north. Between time 12 and 14, the object will return to its origin. It will travel in a negative direction, south. Between time 16 and 18, horizontal line, the object remains at rest. And finally, between 18 and 20 seconds, the object at the origin will move in the negative direction, south, 2 meters in 2 seconds.